Hello students, welcome to Experience Tutor YouTube channel. Today we will discuss NCERT Solution for Physics Chapter 2 Units and Measurement Part 6. Here is our welcome message. Before we move forward, we request you to subscribe, like and share our channel. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Let us begin the chapter. We'll start question number 20. Last class we have done till 2.19. So today we'll start with question number 20. The question is the nearest star to our solar system is 4.29 light years away. How much is this distance in terms of parsecs? How much parallax would the star named Alpha Centauri show when viewed from two locations of the Earth 6 months apart in its orbit around the Sun? So 2.20 distance of the star from the solar system is equal to 4.29 light years. 4.29 light years. It is given in the question. 1 light year is equal to the distance traveled by the light in 1 year. So 1 light year will be equal to speed of light into 1 year is equal to 3 into 10 to the power 8 plus no, this is the speed of the light, 3 into 10 to the power 8 meter per second, and into 365 days, 24 hours, 60 into 60 seconds. Now this value is 94608 into 10 to the power 11 meter. Therefore 4.29 light year will be equal to 4.29 multiplied by 94608 multiplied by 10 to the power 11 meter. So the value is equal to 405868.32 multiplied by 10 to the power 11 meter. Now we have to understand the value of parsec. So since 1 parsec is parsec is equal to 3.08 into 10 to the power 16 meter. Therefore, 4.29 light year is equal to 405,868.32 into 10 to the power 11 upon 3.08 10 to the power 16 is equal to 1.32 per sec. Using the relation theta is equal to d upon small d upon capital T, where diameter of Earth's orbit is equal to d is equal to 3 into 10 to the power 11 meter. Distance of the star from Earth d is equal to 405868.32 10 to the power 11 meter. Therefore, theta is equal to 3 into 10 to the power 11 upon 40586832.32 multiplied by 10 to the power 11 is equal to 7.39 10 to the power minus 6 radian. But 1 sec is equal to 4.85 into 10 to the power minus 6 radian. Therefore, we can write 7.39 into 10 to the power minus 6 radian is equal to 7.39 10 to the power minus 6 upon 4.85 10 to the power minus 6, which is equal to 1.52 second. So this is the answer. Now let us move to the next sum, that is 2.21. Precise measurement of physical quantities are a need of science. For example, to ascertain the speed of an aircraft, one must have an accurate method to find the position at closely separated instants of time. This was actually motivation behind the discovery of radar in World War II. Think of different example in modern science where precise measurements of length, time, mass, etc. are needed. So wherever you can give a quantitative idea of the precision needed. This is a conceptual question, and so in you have to write a detailed answer here. So 2.21, you can write, it is indeed very true that precise measurement of physical quantity are essential for the development of science. For example, ultra short laser pulses, time interval. So you can give an example of ultra short laser pulses. Time interval will is approximately 10 to the power minus 15 seconds, are used to measure the time interval of several physical and chemical processes. So this is used to measure the time interval for several physical and chemical processes. Second example, you can take X-ray spectroscope is used to determine the intermolecular separation or interplanar spacing. So it gives the distance, very small distance. And third, X-ray spectrography, spectroscopy, and the development of mass spectrometer makes it possible to measure the mass of atom precisely. So mass spectrometer. Meter. So this is mass of atom. This is distance, small, very small distance, distance or length, and this is very small time interval. Now let us see the question number 22, 2.22. Just question is, just as precise measurement are necessary in science, it is equally important to have and to be able to make rough estimates of quantities using rudimentary ideas and common observation. Think of ways by which you can estimate the following. Where an estimate is difficult to obtain, try to get an upper bound on the quantity. The total mass of the rain bearing cloud over India during the monsoon, the mass of an elephant, the wind speed during a storm, the number of strands of hair in your head, the number of air molecule in your classroom. So, so 2.22, during monsoon, a meteorologist record about 215 centimeter of rainfall. Say 215 centimeter of rainfall was recorded in India. Now, the height of the water column is, so height of the water column, h is equal to 215 centimeter is equal to 2.15 centimeter. Area of country is equal to 3.3 into 10 to the power 12 meter square. Hence the volume of rainwater is equal to V is equal to A into H, which is equal to 7.09 into 10 to the power 12 meters square. Density of water is, is equal to rho is equal to 1 into 10 to the power 3 kilogram kg meter per meter cube. Hence mass of rainwater is equal to rho into V, which is equal to 7.09 into 10 to the power 15 kg. Now Consider a ship is of known base area is floating in the sea. Measure the depth in the sea, say D1. So consider a ship of known base area is floating is floating in the sea. Measure its depth in sea. Let its depth in the sea is equal to D1. D1. Volume of water displaced by the ship displaced by the ship VB is equal to A D1. Now move an elephant on the ship and measure the depth of the ship D2 in this case. Volume of water displaced by the ship volume of water displaced by the ship with the elephant on board. VBC is equal to A D2. Now volume of water displaced by the elephant displaced by by the elephant is equal to A d2 A minus AD1. Density of water is equal to D. Therefore, mass of the elephant is equal to AD d2 minus d1. Wind speed during a so this is the mass of the elephant. Now the next question. Next question is the wind speed during a storm. So see how can we measure the wind speed of a storm. So wind speed of a storm can be measured by uh, wind speed of a storm can be measured by anemometer. As wind blows, it rotates. It rotates. The rotation made by the anemometer is 1 in 1 second in 1 second gives the value of wind speed. Next question D. So next question is the number of strengths of hair in your head. So area of the head surface carrying hair. So area of the head surface carrying hair is equal to A. With the help of A screw gauge screw gauge, the diameter and hence the radius of a hair can be determined. Let it be r. Therefore, area of one hair is equal to pi r square. Now, number of hair number of strands of hair is equal to total surface area upon area of one hair. One hair, that is a upon r square. Let the volume let the volume of the okay so this is the number of s- mm, strands of hair, a upon r square. So let us see the next question first, then we'll start the answer. So next question is the number of air molecules in your classroom. So E, let the volume of the room, of course the classroom, be V. Now 1 mole of of air at NTP, normal temperature and pressure, occupies 22.4 liter. That is 22.4 into 10 to the power minus 3 meter cube volume. Number of molecules in 1 mole is equal to 6.023 10 to the power 23. Therefore, number of molecules in the room of volume B is equal to 6.023 into 10 to the power 23 upon 22.4 into 10 to the power minus 3 multiply by volume of the room, that is V. So 134.915 10 to the power 26 multiply by 10 to the power 26 V. So upon solving we get 1.35 multiply by 10 to the power 28 V. This is the answer. And this is the end of today's topic. Before we complete, before we finish, we request you to subscribe, like, and share our channel. Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification. Thank you for watching our videos. Thank you.